right, this is our Unit 3 or Chapter 2, the second half, 2B, sample test on rationals. And this part is the calculator portion of the test. I'm going to start out here without a calculator because we should be able to do the information at the top without using our calculator. So I've given you a function here, f of x. It's a rational function, and I've given it to you in two forms. This first form is where everything's multiplied out, and then the second form is in factored form for you. So let's start out and state the information about this thing. So when we look at our function here in factored form, I notice that I have a common factor on both the top and the bottom that I would be able to reduce out. When I reduce something out, that makes a discontinuity, but it's a point discontinuity only at that point. So at x equals -3, I'm going to have a whole because the factor was x plus 3, which when I set it equal to 0 gives me x equals -3, and that's going to be the whole. So down here in the line for whole, I'm going to put in a -3, comma. Well, now I need to know what the y value is of that whole. To find any y value, I just plug into a function, and I plug in the x value. So if I plug in an x value of -3 into my f of x, but this is really my reduced form, then I'm going to have on the top here -3 minus 2. On the bottom, I'll have -3 minus 4 and -3 minus 1. Now when I go to simplify that, on the top of my fraction I have -5. On the bottom of my fraction I have a -7 times -4. So I have -5 over 28, and that would be the y value of this whole. -5 over 28. When possible, we should try to keep this exact. And I like the fraction better than the decimal. So on to the next thing. What other factors we have left on the bottom? We have an x minus 4 and an x minus 1. Those are going to create vertical asymptotes when I set each one equal to 0. These are division by 0 that I cannot remove. There was no canceling of them. So I have x equals 4 and x equals +1, and those are our vertical asymptotes. To decide whether or not we have a horizontal or a slant asymptote, we can't have both. We can either be horizontal or slanted. I think it's easiest to look at the function in the form where it's all multiplied out, and I can tell that the degree on the bottom is bigger. What this tells me is I plug in really big numbers for x, I'm going to have a big denominator, which means my function is going to reduce to 0. So I'm going to have a horizontal asymptote at y equals 0, and my slant asymptote, I'm going to say none. All right, whenever I have an x-intercept, if I have an x-intercept, at any of those points, the y values will always be 0. So to find my x-intercept, I'm going to plug in 0 for y and work backwards to figure out what x is. So if I plug in 0 for y, again, I'm going to plug into my reduced form because if I'm a whole, I can't be an intercept. So I'll have an x minus 2 on the top. Now I'd have these other factors on the bottom, but they're not going to matter because to solve this equation, I'd multiply them over to the left side and they'd just be multiplied by 0 anyway. So I have x equals 2 is the x value of my intercept. It said to state the coordinates of the holes and the intercepts up here in the directions, so I'm writing it as 2, 0. To find the y-intercept, whenever I touch the y-axis, my x value is always 0. So I can just go back into my original function, and I can plug in x equals 0 to figure out what y is. Again, I'll plug into the factored form that's already reduced, so I'd have -2 on the top, I'd have 0 minus 4, which is -4 on the bottom, and a 0 minus 1, which is a -1 on the bottom. So that gives me -2 over 4, which is -1/2, and my y-intercept is 0, -1/2. All right, so I haven't used a calculator at all at this point. I like to do them by hand first so that now I can see, does my calculator match up with what I think it does? Because I know sometimes I have a tendency to put in parentheses wrong. So let's get out the calculator. So in my calculator here, I'm going to go into my y equals, and I'm going to type in, I like to type in the original form of the function, which over here on the test paper, I would put parentheses around the top and parentheses around the bottom. You could also put in the factored version. You just need to be sure if you do that, that you double parenthesis the top and you double parenthesis the bottom. The reason that I recommend the first version is you just do a better job with parentheses. So I've gone through and I typed in this version. And then I want to go to a standard view window, and I'm going to graph it. So I can look, and right now I know my calculator gives me some choppy stuff going on, but it looks like I was supposed to have asymptotes at 4 and 1 according to my vertical asymptote list. And if I check, if I go to trace, and this works on either a TI or a Casio, and I put in a 4, it tells me in the Y value here that I have an error. And that's because right here at x equals 4, I had an asymptote. So I'll go ahead and draw that on my graph too. There we go at 4. I just darkened up my asymptotes a little, or my axes a little bit as well. Now my other asymptote was at 1, x equals 1. I'm going to draw that while I'm here, my vertical asymptote, and then I could check that one as well on the calculator. So I could type in 0 while I'm tracing, and it will tell me, oh, wait, that's the y-intercept. If x is 0, y is -0.5. That was my y-intercept. I meant to type in x equals 1, which was where my asymptote was, and I can see I have another error, so that looks good. All right, let's check my horizontal asymptote. I can tell on my paper it was supposed to be at y equals 0, and I know sometimes it's hard to see when you draw on an axis, but you still have to make the dashed line. If we were checking, remember the horizontal asymptote tells us our end behavior. And if I'm tracing along this function, in the middle I'm not going near y equals 0, but that doesn't matter. If I go for really big values of x, or really negative values of x, my y values get closer and closer to 0. So that's what tells me my horizontal asymptote is 0. All right, let's look at the hole. The hole was at -3 for x. So when I'm tracing, I can type in -3, and again, it gives me an error. If I want to check my estimate for the y-intercept, I can fake my calculator out by typing in something really close to -3. So I'm going to type -2.999, and I can see my y value is -0.1786. I don't know if that's close to what I have, but if I jump back into a regular screen and I do -5 divided by 28, I can see that that's that same decimal. So it looks to me like my hole was in the accurate location. So I'll plot that on my graph. At x is -3, y is down a smidge. I make a nice open circle when I'm drawing that. My x-intercept I had at 2, and my y-intercept I had at -0.5. Again, I could confirm, I already confirmed the y-intercept by accident, but I could confirm the x-intercept on my graph by just typing in a trace of x equals 2. And I can see it does in fact hit at that exact location. If I wanted to get some more points, I should probably go to the table to get these, or I could just trace along the graph. Let me hop over to the table to look there. In my table, I need to be sure I selected the function, and I want to change my setup of my table to go from -10 to 10. And then I'll make my table. I can see these y values for my negative values are below the x-axis. So when I draw them, I'm going to have my arrow down here just on the bottom side of the x-axis, and it's going to come along, it's going to hit the hole, it's going to hit the y-intercept, and then it's going to turn down pretty sharply. If you wanted to confirm that that end was going down in the table, you can see at -3 I had an error, that was the hole. I had an error at x equals 1, but if I wanted to get really close to that, I could do like a 0.99, again, close, and I can see my y values are very negative. Now, if I was on the other side of that, there's my x-intercept, by the way, I could type in a 1.0001, that's really close to 1 on the right side, and I can see that those y values are very positive. So I can tell that the other arrow that I have coming from here is way up in the air, and it's coming down. If I wanted to get some more points, I would just scroll down in the table again. What did I have for x is 3, y is -0.5. And if you wanted to confirm that close to 4, I was in the downward direction, I could type in a 3.99, and I can see that my y values are negative, so that branch is pointing down. And on the other side at 4.001, I could see that my values should be way up in the positive, and I can tell that this arrow is coming up on the top. When x was equal to 5, y was equal to 0.75, so this is making a pretty sharp turn right here. and then it's laying along the x-axis. Again, if I wanted to confirm that y asymptote or the horizontal asymptote, I could just type in a really big number for x, and I can see that's a teeny tiny little number. We have that scientific notation, so it's getting closer and closer to 0. All of my branches have arrows on the ends. I can clearly see the asymptotes, and I'm good to go on this one. For the domain and range, for the domain I'm looking at the x values. I know that x can be everything except a few things. I've got two methods for figuring these out. I can either go back to the original problem and say no division by 0. So up here in the original problem, x cannot be equal to positive 4, x cannot be equal to negative 3, and x cannot be equal to positive 1. Or I could have also looked on my list, x can't be equal to the vertical asymptote or the x value of any holes. So I have all three of those places listed, and I'm good. For the range of the function, I want to think of what y is allowed to equal. In this one, as I look from the bottom to the top, the graph is fine all on these bottom halves because I have a bunch of arrows that point downward. I have to be careful of any vertical or any horizontal asymptotes or holes. So I've got a hole right here, but this branch in the middle is going to skate right through the horizontal asymptote and cover the y value of the hole, so I don't need to worry about anything. I simply have y as all real numbers, and my y values are all covered by that branch in the middle. All right, so if I turn the page here, I've got another function. Again, I'll try to answer my information here without a calculator. So I look at my original form. First thing I want to do is see, is anything going to reduce out? I have an x plus 7 that's going to reduce out from the top and the bottom, and that creates a hole when the x value is equal to negative 7. To find the y value, because I'm supposed to state the coordinates of the holes, I need to go ahead and plug back into the original function. I'm plugging in to f of 7, the reduced version, not the real one. F of negative 7 is going to be does not exist. So I have negative 7 minus 1 and negative 7 plus 1 on the top. On the bottom, I have negative 7 minus 2. So my first factor is a negative 8. My second factor is a negative 6. And on the bottom, I have a negative 9. So let's see, can I reduce some here first? I can take a 3 out of that and a 3 out of that, and then I'm easier at using my calculator. I would have 16 on the top and negative 3 on the bottom, so negative 16 thirds. And we need to look at what other factors we have left on the bottom that didn't reduce out. I've got an x minus 2. That's going to create a vertical asymptote at x equals 2 because I'm not allowed to divide by 0. In terms of finding the horizontal or the slant asymptotes, I want to go back to my original function. As I plug in huge numbers for x, the top is going to win out on this, and it's going to keep getting bigger and bigger and bigger. So it's not going to have a horizontal asymptote, it's going to have a slant asymptote. To find the equation of the slant asymptote, I need to divide this function. So I'm going to have a kind of a nasty division here. I've got the bottom that's going to be going into the top. So my factor over here on the side of the box I've drawn, being one of the dimensions, is x squared plus 5x minus 14. And I have to have the top of the fraction in to represent the area of the box. So I'm going to start out, I'm going to put in an x cubed, which means on top I must have had an x. So if I'm multiplying, I would have had a 5x squared in this box. I would have had a negative 14x in the box beneath it. And then I've got to make sure I actually need 7x squareds in the original problem in my box. I have 5x squared so far, so I need to put another 2x squareds into the box, which means on top I would have had a plus 2. Now the nice thing is at this point, I can really stop because everything else is going to be remainder. I can see, I'll just show you if I keep on going with this. I have a 10x down there. I have a negative 28. Now, if I were trying to figure out how many x's I need a negative x total from the problem. So far, I have negative 14 and positive 10. So I'm at a sum right now of negative 4x. I need negative 1x, so I would need to add 3x more, and I can see that when I go to put a number up here on top, since that degree of the x squared is bigger than what I'm dividing by, I know everything else is going to be a remainder. So my slant asymptote is y equals x plus 2. The other way I could have done this was I could have looked at just the reduced form, and then I would have had to multiply out the top and divide it by the bottom, which might have been a little easier in this case, but I wanted to show you we can definitely do a division problem where we're dividing by an x squared. It's not a problem. All right, so let's look at our x-intercepts and our y-intercepts. In any x-intercept, the y value is always going to be 0. So that would mean the top of the fraction is equal to 0, which would happen when x is 1 or when x is negative 1. To find the value of any y-intercept for any function, that means our x value is going to be 0. And if I plug in x equals 0 to my original function, I'm plugging into the reduced version, I have negative 1 times positive 1 over negative 2. So that's negative 1 divided by negative 2, which is a half. And now I'm ready to go ahead and start making my graph. So I'm going to type this into my calculator. Again, I'm going to put the top of my fraction in parentheses. Close the parentheses, divided by the bottom part of the fraction in parentheses. When I go to graph, I want to go to a shift view window and be sure I'm in a standard window. And I can see this looks like it has a nice slanted asymptote. I myself would like to go back. I'm going to exit. I'm going to write in the equation the slanted asymptote just to check that as well. If I type in x plus 2 as a second function, you don't have to, but you can change the style of your line to be a little dashed line and it'll look like an asymptote when we draw it. And there we go. That looks like the right asymptote. By the way, I also could have done that for the x asymptote if I wanted to. I could change the type of my line to be x equals a constant, and my vertical asymptote was at x equals 2. And again, I'm going to change the style of that line to be dashed, and you can see there both of my nice asymptotes are drawn. So when I go to put these on by hand, I have x equals 2, so I'm going to draw that. I also have y equals x plus 2. That would have a y-intercept of 2 and a slope of 1. So you do need to plot that nicely when you're making your paper graph. Notice I keep going. I'm making my little dashed lines, but I'm making them in the right spot for a slope of 1 and a y-intercept of 2. I'm going to scroll this guy up a little bit so I get more of the bottom of the graph on here as well. Let's see, I needed a hole at x equals negative 7. Y was negative 16 thirds, which I would rather think of that as a fraction. As a fraction, negative 16 thirds, 3 goes into 16 5 times, and I'd still have 1 left over. So my y value is negative 5 1/3. So 1, 2, 3, 4, 5 1/3 down is going to put my hole right there. And I could double check on my calculator. If I went into trace, I can either try to get close. If I just jump over to negative 7, it's going to tell me I have an error. But again, if I do like a negative 6.99 and try and fake it out, it tells me negative 5.3, which was really close to my negative 5 1/3. And that looks good. Let's check my x-intercepts while I'm here. I had an x-intercept of 1, I thought, which I can see that does work. I had an x-intercept of negative 1, which I check out, that does work. My y-intercept, x was 0, and that gives me a y-intercept of 1/2. So I've just confirmed all those points that I need to plot, and I'll put them on my graph. X is negative 1 and 1 are my x-intercepts, y-intercept of positive 1/2, and I draw my function. It was laying beneath the asymptote, and then it peaked up and went down. I had plenty of points plotted on that one. I need some points plotted on this branch over here on the right. To do that, I can either jump over and I can type in my calculator when x is 3, y is 8. I can check 4 when x is 4, y is 7 1/2. When x is 5, y was 8 again, or I could have just gone into the table and looked there instead. Okay, so that's looking good. I need to state the domain and range for this function in number 6. So for the domain, I can tell that x is not allowed to divide by 0 in any part of the fraction. So x would not be allowed to be the -7, which was the x value of the whole, or the +2, which was the x value of the vertical asymptote, the two places where the bottom of the fraction was 0. For the range, if I'm looking from top to bottom, I have this gap right here in the middle where I have no y's, right? No y's in there. So what I need to do is I need to figure out what's the highest spot or the maximum of this branch, and what's the lowest spot or the minimum of that branch. To do that, I need to go on my calculator. I just deleted that other stuff to get it out of the way. So I go to GSolve, I hit max, and my calculator tells me that right here I have a max. The x value is 0.2679 and the y value is 0.5358. So since I go from this spot down, I know when I'm writing my range, I would say y is less than or equal to 0.5358, or my y can be greater than or equal to whatever this spot is. So I'm going to need to find that. That technically was the minimum of this branch. So in my calculator, I go to GSolve min, and it tells me there my x value is 3.7320 and my y value 7.4641. So I have y is greater than or equal to 7.4641. I didn't really care about the x values of these points because they were included in the domain. I really only needed the y's for the range. If I were going to do increasing and decreasing, I would need to know these x values, but not for domain and range. All right, nothing else down on this page, so let's turn over to the next one. We're now on the no calculator part of the test. So I put that away. It says what line is a vertical asymptote of f of x right here? And I know that this factor is going to reduce out and make a whole. So the vertical asymptote comes from any factors on the denominator that do not reduce out. And I have x equals -4, which was answer choice A. Question 8 said, what line is a horizontal asymptote? So I'm looking at the degree of these functions and thinking, if I'm plugging in really big values for x, what's going to happen? None of this is going to matter. It's going to reduce out, and all I have left is the 2/5. I need a y equals for a horizontal line, so I have y equals 2/5. Number 9 asks, which line is a slant asymptote? I can tell it's going to be a slant asymptote because when I divide, I would have x's left on top. So if the top wins out, I'm going to have an end behavior that approaches infinity, and it's going to be slanted. In order to figure out the equation of this thing, I'm going to need to do division. So I want to know, how does x plus 2 go into this quadratic on the top? So I'm supposed to have, this is my product, or the inside of the box. So I have 5x squared in there, which means on the top I'd have 5x. On the bottom I'd have plus 10x. But I'm not supposed to have 10x, I'm supposed to have 3x, so I need to take away 7x's, which means on the top I have -7. The rest is just going to be remainder at this point, so I don't need to worry about it. In the grand scheme of things, when I start plugging in huge numbers for x, the remainder is insignificant, and my slant asymptote is y equals 5x minus 7. In number 10, I need to state the domain. For the domain, the bottom cannot equal 0. This one's going to reduce out, but that doesn't matter because it'll still be a domain restriction. X cannot equal -1/2 because that's going to be a whole, and x cannot equal +3 because that's going to be a vertical asymptote. So my answer is C. I don't care where the top is 0 in any function. In this one, it really doesn't matter because it was where the bottom equaled 0 anyway. All right, number 11, I'm supposed to state the equations of the asymptotes and the coordinates of the holes and intercepts. I do not like this written out in multiplied form, but I can factor those things. So let's start with factoring the top. I have to factor 3x squared plus 7x plus 2. So I know this is my product. I have a 3x squared and a plus 2, and I'm trying to split up the 7 between the two boxes remaining. So how can I multiply to 6x squared and add to 7x. Both things are going to have to be positive to multiply and add to a positive. Both things are going to have x's with them. And 6x times 1x equals 6x squared, and 6x plus 1x equals 7x, so that's how I'm going to split up my numbers. I take the GCF of the top row as x, so that means my factor on the top here should have been a 3x and a plus 1. On the bottom here, it must have been a 2, and then if I check, 2 times 1 equals 2, so I can factor the top into 3x plus 1 times x plus 2. The bottom was x squared plus 2x minus 3. Since this one didn't have a leading coefficient, I can just jump straight to my factors. What two things multiply to negative 3 and add to positive 2? Well, that would be a positive 3 and a negative 1, so that's going to be factored. All right, nothing in this is going to reduce out. So when my bottom equals 0, I'm going to have vertical asymptotes. I'll have two vertical asymptotes at x equals negative 3 and at x equals 1. To determine my horizontal asymptote or my slant asymptote, I'm going to look at the degree at the top and the bottom. Since they're equal, as I plug in really big numbers for x, all of this extra stuff becomes insignificant, and my coefficients were 3 over 1, which is just 3 for my horizontal asymptote, meaning I don't have a slant. There are no holes for this because I didn't have anything that canceled out. X-intercepts is where the y value of the function would equal 0. So that's where the top of this function is equal to 0, because the bottom, remember down here, would just multiply and be gone anyway. So I have x equals negative 1/3. I got to write it as a coordinate, so negative 1/3 comma 0, and also x equals negative 2. To find the y-intercept, I'm going to plug in x equals 0, because my x value has to equal 0. When I plug in 0 to this function, I have 1 times 2 on the top and 3 times negative 1 on the bottom. So that's y equals negative 2/3. Okay, on the last page, we've got some solving problems here. For number 12, I'm supposed to solve and circle my answers because remember, sometimes I get extraneous answers on these. In order to figure out my extraneous answers, I'm going to start out by factoring this problem. My first was x squared plus x plus 2. That's not going to factor. It had an x plus 1 on the bottom. I'm going to leave myself a little room to go back and work. My second thing was just x. If I had to write it as a fraction, it'd be over 1. And over here in my last fraction, I have x squared minus 5. And if I factor out the bottom of x squared minus 1, that factors into x plus 1, x minus 1. So I can tell I'm not allowed to divide by 0. So I've got to double check in this problem, x cannot be equal to negative 1 or positive 1. If I get that as an answer, I'm going to have to go back and cross it out. So what I don't like about this problem is that it's fractions. How do I get rid of the fractions? I multiply the whole thing through by the least common denominator for the problem, which is x plus 1 times x minus 1. So I'm going to take every term times x plus 1, x minus 1, x plus 1, x minus 1, x plus 1, x minus 1. And why did I do that? Because now I'll reduce, and I have no fraction in the first term. I already had no fraction in the second term, and I can reduce both factors, and over here on the right, all I'll have left is my x squared minus 5. So let's clean up the left. I had x squared plus x plus 2 times x minus 1. Well, let me work that out. X squared plus x plus 2 times x minus 1. So that's going to be x cubed plus x squared plus 2x minus x squared minus x and minus 2, which if I combine like terms as I'm writing these down, I have the x cubed. My x squared and minus x squared cancel each other out, and I'm left. Positive 2x and negative 1x is positive x. I also had a minus 2. Going over to our second bit right here, I've got x times x plus 1 times x minus 1. Well, I know that x plus 1, x minus 1 was the x squared minus 1, so I just need to distribute into that. So the second term turned into x cubed minus x. Remember that I was really subtracting this whole thing. So I had x cubed plus x minus 2. When I distribute the subtraction, I'd have negative x cubed, and this would turn into plus x equals x squared minus 5. I just scooched that other work over. So this is a cubic, but in reality I have an x cubed and a minus x cubed, so it's not even a cubic. It's actually a quadratic. That was my biggest power. To solve a quadratic, I like to set it equal to 0. I'm going to move everything over to the right because that was where my x squared was positive. So I've got to take this plus x and this plus x, so I have 2x on the left. When I move it over to the right, that will be minus 2x. I had a minus 2 on the left, so when I move it over to the right, it will add 2 to both sides, and I'll have negative 5 plus 2, which is minus 3. This is hopefully something I can factor nicely, and it is. What two things multiply to negative 3 and add to negative 2? That's x minus 3 and x plus 1. Then I set each factor equal to 0. I get x equals 3 and x equals negative 1. I feel good. I'm thinking I'm done. I go to circle my answer. X equals 3 is fine. But remember, x can't be equal to negative 1 because back up here at the top, that would have given me division by 0 in the original problem. I can't say and write extraneous at the same time. That's an extraneous solution. It's one that worked out mathematically that did not make sense in our original problem. All right, so let's scroll down to number 13. This one's already nice and factored for us. So I just need to multiply both sides. Let me rewrite it. I have x over x plus 7, and then I have minus 1 over 8 equals, I'm going to write the negative on the top. Otherwise, sometimes I lose the negative. Oftentimes I'll do this too. I'll call that plus a negative, and then I don't have any subtraction to worry about. All right, so I got to multiply both sides by the least common denominator for the whole problem. So I'm going to multiply by 8 times x plus 7. I'm going to multiply that to every single term. I have to stay balanced. In order to stay balanced, I always have to do the left and the right in an equation. Okay, so my x plus 7's reduce out, and my first term is now just an 8x. Over here, my 8's reduce out. This is a negative 1, which I'm going to distribute to both terms in that binomial. So I have a negative x and a minus 7. Now my x plus 7's are going to reduce out, and 7 times 8 is 56, and that was negative. So this is just a little linear equation. There's not even any exponents in it. 8x minus 1x is 7x. I'm going to add 7 to move that over to the right. And negative 76 plus 7 is negative 49. To get rid of the 7, I'm going to divide both sides by 7. And I have x equals negative 7. So I'm thinking that sounds great, and then I realize, oh, I never went back in the first step and said, what do we have here that's a problem? X can't be negative 7 in this problem because that would create division by 0. So this does not work. It's extraneous. If the only solutions you have are extraneous, that means your problem has no solution. You can either write the empty curly brackets or you can write no solution. But you need to put something that indicates you understand there is no answer to this problem. Okay, we only have one problem left, and it's a word problem. So let's start out. It says, if they work together, Kevin and Mark can wax a car in 2 hours. So let's write that down. Together is 2 hours. Working alone, Kevin takes 3 hours longer than Max working alone. How long would it take Mark, oh, I changed the name, Max became Mark, to wax the car working alone? Sorry. So I've got Kevin, and I've got Mark, or Max, whatever you want to call him. I don't know how much each of them take. I do know that Kevin takes 3 hours longer than Mark. Sorry. And I know I'm trying to figure out how long would it take Mark. So let's call Mark M, right? The amount of time it takes Mark is going to be M hours. So the amount of time it takes Kevin is 3 hours longer than Mark. So he's going to be M plus 3 hours. So this is the amount of time required. I need to look at basically the rate, or how much work do they get done. Well, doing this, Kevin can do 1 over m plus 3. That's one car in m plus 3 hours. Mark can do one car in m hours, and together they can do one car for every 2 hours. So what I'm doing here is I'm adding Kevin and Mark together to get the together total. So I have 1 over m plus 3 for Kevin's rate. I have 1 over m for Mark's rate. And together that has to equal one car in 2 hours. So this is the rational equation that I'm solving. In order to solve that rational equation, I need to multiply both sides by the least common denominator. The least common denominator in this problem would be m plus 3 times m times 2. So I have an m plus 3 times m times 2. m plus 3 times m times 2. That allows me to do some reducing. So in my first fraction, all I have left is 1 times m times 2, which is 2m. In my second fraction, my m's reduce, and I have 1 times m plus 3 times 2. So the 1 doesn't really matter. I'm just going to distribute the 2 to both things in this. I have it now at 2m plus 6. Then I had the equal. Don't forget where the equal to problem is. Next one, only the 2 reduces out. So I'm going to reduce the m, and I'm going to have m squared plus 3m. This problem is now a quadratic because it has an m squared in it. I'm going to scroll down a little here. So I'm going to set it equal to 0. I have m squared. I'm going to move. I have a total of 4m over here on the left. So when I subtract them to move over to the right, I'll have 3m minus 4m, which is negative 1m. I've got 6m over here on the left. When I move it to the right, it will be a minus 6. So now I can factor. I have what two things multiplied to negative 6 and add to negative 1. That's a negative 3 and a positive 2. Since there's no leading coefficient, I can just jump right into my answers. Set each one equal to 0 gives me m equals 3 and m equals negative 2. Now we have to go back and think about the problem. M is the amount of time it takes Mark to wax the car. Well, Mark can't wax a car in negative 2 hours, so we've got to cross that solution out. And our final answer is it takes Mark 3 hours working alone. Okay. All right. Thanks. Good luck on your test.